So the first thing that we have is just a graph that's really zoomed in around 2 units for x and y's. We're going to graph the first 3 even degrees. So the first one I'm going to graph, and I'm doing that one in pencil, is y equals x squared. So I'm graphing just the really basic one, the parent function. There's no stretches, shrinks, translations, reflections, nothing. If there's nothing happening to it, the parent function has a vertex at 0, 0. It has a point at 1, 1. It has a point at negative 1, 1, and we know it's a parabola. It looks something like that. I'm just sketching it. It's not perfect. The next one I'm going to graph is going to be y equals x to the 4th. And again, there's no stretches or translations, nothing done to it, so it's just a parent function. It also has a center at 0, 0. It also passes through 1, 1 and negative 1, 1. But other than that, it like starts slower, but then once it passes 1, 1, it rises faster than the squared function. So it kind of starts slower, but once it passes through 1, 1, it rises faster. So it has this like flatter part in the middle. Unless we have stretches and shrinks and translations, and then it does crazy W things. Or if it's just the parent function, that's what it looks like. And then I would just do one more. We'll do y equals x to the 6th. It also shares those 3 points, but it starts slower, and then it rises faster. On the other graph, I'm going to do odd, so I'll do y equals just x to the 1st, and that's a line. It's going to go through 0, 0. It's also going to go through 1, 1, and negative 1, negative 1. Then I'm going to do y equals x to the 3rd. That passes through 0, 0. It passes through 1, 1. It passes through negative 1, negative 1. But it starts slower and then rises faster. This point in the middle for the cubic is called a point of inflection. It's not called a vertex like it would be with the quadratic. It's just called a point of inflection. It kind of means the same thing. And then y equals x to the 5th will also share those same points. It's just going to start slower and then rise faster past the 1s. Bless you. That's what the power is doing. Okay, the next section is what we were just talking about with end behavior. And last year in Algebra 2, you should have learned about end behavior, which I don't know if you remember, but I'm going to be using symbols that I would expect you to be using in homework and on a quiz or test. And if I'm confusing you with the symbols, just ask. We can help you. So the first thing we're going to talk about, if the degree is even and the leading coefficient is positive. So we're talking about a degree that is even, so both of them are going to go the same direction, and it's positive, so which direction are they both going to go? Up. So I just sketch over here. I know that the ends are both going to be going up. I don't know what the inside is doing. I know that the ends are going to be going up. The symbols for these, we're always going to start with the left side. So I'm going to look at this left side. And when I look at this left side of the graph, you say, hey, the graph's going up on the left. You say that graph's going up on the left. To show that symbolically, we say the function f of x is approaching positive infinity. That's saying the graph is going up. As the x values are approaching negative infinity. That's saying to the left. So the graph itself, the function is going up as the x's go to the left, as we go to the left. And then for the right part, for the right side, I look at my arrow and it's going up. So I say that the function f of x is going to positive infinity, means up, as the x values are now going to positive infinity, because that's to the right. So f of x is up or down, and x is left or right. And in every single scenario, we're going to talk about the left first and then the right first. So this part that says as x approaches will be the same for every single one. That last part will be the same for every single one. So the second one, if the degree is odd and the leading coefficient is positive. If it's odd and the leading coefficient is positive, that's the graph that like starts down and goes up. So now I look at my left side of the graph and I say, all right, my function is going down. So f of x approaches negative infinity as x approaches negative infinity. So we say to the left, going down to the left. And then the second part, f of x approaches on the right side, it's going up. Approaches up as x approaches positive infinity. The third one, if the degree is even and the leading coefficient is negative, you should be like thinking right now what that's going to look like. It's even, like squared, negative. Yeah. So we know it's going to look something like that. I don't know what the inside does. I just know the ends. So to the left, it goes down. F of x goes to negative infinity as the x values go to negative infinity. And to the right, f of x goes to negative infinity as the x values go to positive infinity. And then the last one, if the degree is odd, leading coefficient is negative. We know the ends are going to look like that. We're going to say the function on the left side is going up. So f of x approaches positive infinity as x approaches negative infinity. And then f of x approaches negative infinity as x approaches positive infinity. So you see the as x part is the same for every single one of them. It's those y's that we're talking about change, up or down. If you are ready to go on, flip the page so I know that you're ready to go on. And then you can look at the next question. So question A, in order to figure out what the end behavior does, you have to find the first term, the term that tells you the degree and the leading coefficient. What do you think the first term is? Negative 2x to the third. So we can find the degree, which is the highest exponent. So it might not be exactly where you are looking. Don't always look just at the beginning. Just think about it. So the degree for this is 3, and the leading coefficient is negative 2. So my leading coefficient, and I don't really care what number it is, all I care is that it's negative. And then my degree, it doesn't matter what number it is. What matters is that it is odd. So if we have a negative in an odd situation, then we're looking at a graph that looks something like that. I don't know what it does in the middle, and I'm not asked to find that right now. So we have to write the end behavior. F of x goes where first? Positive infinity, as x goes to what's to the left? Negative infinity. And then f of x goes to, on the right side, it goes down as x goes to positive infinity. So how about question B? Find your first term in question B. And then we need to determine if the leading coefficient is positive or negative, and what the degree is, so we know if it's odd or even. What do you guys think? Leading coefficient. Well, what term is the first one? Which term? What do you think we need? Oh, 4 x to the 6th. Is that what you're saying? Yeah, that is the one. And it happens to be first. Yay. So our leading coefficient is a positive, and our degree is even. Positive, even. Looks something like that. That was messy, sorry. So f of x approaches positive infinity as x approaches negative infinity. And f of x approaches positive infinity as x approaches positive infinity. Questions on end behavior? So what we're doing is we're working up to being able to graph like these crazy functions by hand. So we need to understand end behavior first. We need to know what the ends do. The next part talks about the fundamental theorem of algebra and the linear factorization theorem. What we're saying here is any polynomial can be factored into linear factors, meaning all of the factors are going to have x to the first. And then there might be plus or minus some other things in there. But every single polynomial can be factored so that we have x to the first. Let me give you a polynomial example that you guys could try to factor. Just put off to the side here. X squared plus 4 equals 0. Can you help me factor that? What do you think? What is the degree? So how many factors should there be? 2. Each factor will have 1 power. So we know that there's going to be 2 factors. So how can I FOIL that back together and get plus 4? Okay, don't write that down. If I FOIL that back together, the outer and inside will cancel. I will get x squared, but what do I get for my last term? I get negative 4. So it's not going to actually work. So we're on the right track. Do you know what it is? Okay, don't write that down. So that is going to give me plus 4 now. But when I do my outside and my inside, I'm going to get negative 2x and negative 2x, and those don't cancel. How can I find what x actually equals besides factoring? What other methods? Don't tell me you don't know. We did it yesterday. You could do probably a formula, or what's the other one? We could do complete the square, but this one's actually squared already, so we could just solve it with square roots. If I move the 4 over and I square root, I'm going to get the answer. So if I move that 4 over, it becomes negative 4. What happens when I square root that? What do you get? 2i. So this is actually 1 plus and 1 minus 2i. It can be factored. They're just like, you can't graph them because they're imaginary. But these are saying that every single polynomial can be factored, and we will be factoring out every single polynomial all the way. Eventually, not today. Okay, so we're getting towards that. But that's what those theorems say. So now, here we have some polynomials that are factored, some that aren't factored. We have to write what their zeros are and if there is multiplicity with the zeros. And I'll explain that as we do it. But the zeros, we get zeros from making f of x equal 0. So in this first, or p of x, make it equal to 0. We say 0 equals x plus 3, x minus 2, x plus 1. Now, when you solve for x, you are finding the zeros. Is there graphically something that we know that that the x's are also equal to when it's 0? Graphically on the graph, what is it? We plug in 0 for f of x, what are we finding? X-intercept. We're finding the x-intercepts. But we're calling these zeros because all you're doing is plugging in 0. We're not really relating it to the graph, but it is related to the graph. All right, here we go. What do you do now? Set each one equal to 0. So you have x plus 3 equals 0, x minus 2 equals 0, x plus 1 equals 0. Solve each one. And we have zeros as -3, -1, 2. Notice how I did not write those as x-intercepts with ordered pairs, but I wrote them as a list of numbers. Because we were just listing zeros, we're not writing intercepts. That means different things, even though they'll be later. Okay, did any of those occur more than once? So there's no multiplicity. What's the degree of that first question? What was the degree? The degree was 3, and how many solutions, or how many zeros did we get? 3. Exactly the same number, so there's no multiplicity. How about the next one? Set equal to 0, find the zeros. Is it too warm in here? If you're struggling, stand up. If you're struggling. Do I need to set 4 equal to 0? Yes. No. No. Why? Why don't I have to set 4 equal to 0? There's no x in it. We're trying to find what x equals. There's no x in 4, so you don't need to worry about that. Question? Okay. So I'm just going to set x plus 7 equal to 0 and x minus 3 equal to 0. I'm not worrying about those exponents yet. So I get x equals -7 and x equals 3. So my zeros, we have 1 at -7. However, because it was squared, we actually have how many at -7? 2. So this has a multiplicity of 2. And then my other 0 is 3. But that occurs how many times? We have a multiplicity of 3. And two -7s, 3 3s gives me a total of 5. And if I were to multiply this all out, which I'm not about to do, but if I were to FOIL all of that out, distribute it all out, I would get x squared, x a third, I'd get x a fifth. I'd have a degree of 5. So I have the exact same number of answers as I do my degree. Okay? Next one. When I look at this, I see it kind of factored, but it's not totally factored because we don't have linear factors. We have x squared as our factor. So that means I have to actually take that factor x squared minus 7x plus 12 and factor it more, if it'll factor. Otherwise, I just solve for it. Will that one factor? All right, factor it. I factored that, and because the whole thing was squared, we've got 2 of each factor now. So I've got 3, the multiplicity of 2, and 4 with the multiplicity of 2. I had tried the next one. You got to factor that next question. How? But this is to the first power. So you can. Alright, so factor the next one, the h of x. What's your first step of factoring? Oh, wait. Is there a GCF? Take that baby out, you'll make it a lot easier to factor. What is our GCF? Right, x squared. Oops. So once you have it factored, if I have x squared, I'm going to ignore the squared part. The square just means there's a multiplicity of 2. I'm just going to set x itself equal to 0, x minus 5 equals 0, and x plus 4 equals 0. So we've got the number -4, we've got 0 with a multiplicity of 2, and then 5. All right, next one. How do we factor 4 terms? Woo, good. Grouping. When you group them, make sure you have a plus sign in between, and then that minus sign goes with the 25 into the parentheses. When you're doing factor by grouping, your next step is to see if you can factor x cubed minus 4x squared. Is there a way to factor that binomial? How do you factor it? Huh? Oh, x squared? Yes. GCF, x squared. So then I start thinking ahead. Is there a way to factor the other parenthesis so that it has an x minus 4 left over? Is there? Take out what GCF? A negative 25. So that we have an x minus 4 left over. And we did that because now these are terms. And from these terms, we're going to factor. And when I'm looking at these terms, they both have a greatest common factor of x minus 4. So I'm going to pull that out. And I have left over x squared minus 25. And I've factored by grouping. Are all the factors right now linear? Then I have to factor x squared minus 25 further. But that's just a difference of squares, so that one's not bad. And then I just skipped the step where I said it equal to 0, because that one, I hope you can figure out this pattern. If it's just a single number, you don't really have to set it equal to 0. I mean, that's what you're doing, but you don't have to show that stuff. No multiplicity. All right. Are we hanging in? Kind of. Go ahead and turn to page. We're going to skip example 3 for right now. We're going to come back to it. Go to whatever's next. Example 4. Okay, so we're skipping example 3. We're going to come back to that. When I go to example 4, we're going to find a polynomial function with the given zeros and multiplicity. That's kind of what we started doing yesterday.
Here it's telling us we have a 0 at 0 with a multiplicity of 2, and then we have a 0 at negative 3. So I'm going to start with making this look like x equals.
So whatever x equals, I set it there. And then I'm going to take each of what x equals and make it say equals 0. So this first one already says x equals 0. For this one, I move the 3 over and I get x plus 3 equals 0. Those are the factors. So I'll write f of x equals x multiplied by x plus 3. And then I'll pay attention to the multiplicity. Since 0 has a multiplicity of 2, how do I show that? I just put the squared on the x, like that. Okay, the next one, we're going to start by saying x equals first. Then you make them say equals 0. And then this we looked at yesterday. Do you ever factor polynomials and end up with like fraction factors? You don't. So you're going to have to take these fractions and multiply everything in this equation by the denominator 7. And then for that one, we're going to multiply everything by the denominator of 3. So you'll end up with 7x minus 6 equals 0 and 3x minus 4 equals 0. So I have x plus 2 is one factor, 7x minus 6 is another factor, and 3x minus 4 as a third factor. Yeah.
So why did we multiply those?
By the 7 and the 3?
Yeah, why?
Okay, so when we were factoring, let me just go back. We did this yesterday when you weren't here, but well, there's not great examples on this side, but like when you go to factor these, do you ever end up with like x plus a half or x plus 6/7 when you're doing factoring?
Not really.
You never. We always factor with integers. So because what we're doing is we're writing the factors, because there's fractions here, I know that those can't be there. So what I'm doing is this is an equation, so you can just multiply both sides by whatever the denominator is, and you get rid of the fractions. So now if I were going backwards and I was given this, and I were trying to find the zeros, then I'd like move the 6 over and I get a positive 6. And then I divide both sides by 7 and I get 6/7. So that's just how we're undoing the solving part. Okay. All right, next one. You guys read it. Find the polynomial of degree n that has the given zeros. So you're finding the 0 at negative or at positive 9, and it has to have a degree of 3. So you write x minus 9 equals 0. That is the 0. So what's it look like? How do I make it that a degree of 3? Parentheses cubed. So now there's only one 0, but it has a degree of 3. Can you start question B? That's going to be a degree of 7. I'm just walking around to see that you guys got the 3 factors correct first, not so much the degree. But you're doing x equals negative 2, so that'll be x plus 2. X equals 0, which says x equals 0. And then x
equals 1/3. So x minus 1/3 equals 0. Do I have to leave this as a fraction? I got to change it by multiplying everything by what number? 3. So we've got f of x, or whatever x you want to choose. We've got an x, we have an x plus 2, and we have a 3x minus 1.
Right now, when I look at this, what is the degree? 3, but it needs to be 5. So you're going to have to put some exponents on, but there really isn't anything that tells you which ones get the exponents, so we could have multiple different answers here.
I just have to have a total of 5. So if I have 1 for the 3x minus 1, 1 for the x plus 2, maybe I have 3, x to the third. Maybe that's what I do. Or maybe x and then x plus 2 squared and then 3x minus 1 squared.
There's multiple different answers for this one. Yeah.
So if you don't have anything, is it already 3 or is it only 2? Because you count the parentheses.
You count each x as one of the degrees. Because each x to the first is one of the degrees. So before I put any exponents in, there were 3. So I need to make a total of 5, right?
So you add 2 instead. Like 3 to x.
I added 2 more x's on. Is that what you're talking about? Yeah, I added 2 more on, so it made 3 total.
Okay.
And then there's the fourth one, and then there's the fifth one. Or for this one here, I left it as 1, then 2 more, and then 2 more, so that makes 5. So, like, there's different answers for that. All right, last one. Last one. Right here, let's see, we've got a 0.
We've got 3 zeros given, but we need a degree of 4.
So I have 3. There's only one way I could do this one properly to make it a degree of 4. Does anybody think we know? There's only one way that I'll do it. Square the x.
Why would I not square maybe the square root 2, like this one?
So something you should have learned in Algebra 2 last year is when you FOIL back together square roots or imaginary numbers, they're always conjugates, they're always opposite of each other, and they always come in pairs. There's always even amounts of them. So if we have a square root 2, then we have a negative square root 2, there aren't going to be any more. Okay, so those always come in pairs. So that's why I knew to prove it. Okay, we can start this. We just have a few more minutes before we go to lunch. We can start this and we'll finish it after lunch. Here, we're going to do, you guys find the leading coefficient, and we're talking about positive or negative. Sorry to think. Degree is odd or even. And then the end behavior is the f of x stuff. Factor and find all the zeros. It should be factored already, so you can find all the zeros, what we just did. List them out. We should know how to find the y-intercept. What you aren't going to be able to do yet is relative extrema, and then finish the graph. So you should be able to do through y-intercept right now. Okay? So try it. I'm not sure if you're going to try to call me over and stuff. So we're just going to be like uneven, plus and negative. We don't actually have to put a leading coefficient. Yeah. Yeah, and then the f of x goes to yeah. All right, so the leading coefficient for the first one is not 1/2. It's not 1/2. It's not positive either. It doesn't go any further.
This is not like in
Terms. You have to kind of multiply it back together. You don't have to multiply the whole thing. We just have to know about the first term.
So you have to multiply together this with that term with that term.
And you don't even need to know the number, you need to know if it's positive or negative. So if I multiply together 1/2 x squared, negative x, and 2x, am I going to get a positive or a negative?
I'm going to get a negative answer. And then for my degree, if I'm multiplying together an x squared and x to the first and then 2x to the first here, that's 4. So even.
So in your homework, it's going to be factored like that. You're going to have to think about putting it back together to actually know if it's positive or negative, or even or odd. All right, now stop talking. So answer the next question. F of x approaches what? If you draw that little picture, it might help you. Next, you're going to factor find out to 0. It's already factored. You're going to find out to 0. And I think you have to talk about multiplicity too. Yep. In the homework, I think it says multiplicity as well. And then how do we find the y-intercept? Put 0 in correct. Plug in 0 for x.
I start plugging in 0 for x, and the first x that I plug it into, I should know the answer already, even though I'm writing the whole thing.
What happens when you plug in 0 for x right there? And it multiplies by everything. You get 0, so this will be 0 there. Have a great lunch. We will finish when we get back. Go do some laps around school too. Go wake up. Go drink some water.